Hi, my name is Mariana Ruelas, and I'm going to be doing the problem exercise from the textbook 8, from section 8.2, number 11, and from the My Math Lab homework, it's 8.2, exercise 4. So the question says, suppose a simple random sample of size n equals 150 is obtained from a population whose size is capital N equals 10,000. And whose population proportion with the specified characteristic is P equals 0.2. Complete parts A through C below. So section A says describe the sampling distribution of P hat. Choose a phrase that best describes the shape of the sampling distribution below. So these are our options. So we have to decide whether it's normal or not normal based on using this formula right here. This is the correct formula. So it's either going to have to be between this one or this one. So first we have to plug in the N, the lowercase n, which is this one, and the capital N, which is this one. And then for the P, it's going to be 0.2. So we go ahead and plug that in into both of these equations. And then from there, we'll be able to determine if it's approximately normal or not normal based on those results. Alright, so I have the formulas right here and the N, P, and capital N. So we go ahead and plug that in. Let's do this one first. So it's going to be N is 150. It's greater than 0.0. Okay, so now we're going to use a calculator for that to multiply 0.05 times 10,000. So this is true. So now we're gonna do this one right here. So n equals 150. Lowercase n equals 150. The p is 0.2, and then 1 minus p is 0.810. So we go ahead and multiply this right here. So this is true as well. So since these two, so now that we plugged it in and they're both true, that means it is approximately normal. So the problem will be answered like this. Since both of them were true, so then it's going to be the phrase that best describes the shape of the sampling distribution below is that it is approximately normal because lowercase n, etc., and np, close parentheses, open parentheses, 1 minus p, close parentheses, is greater than or equal to 10. So now we need to determine the mean of the sampling distribution of p hat. So as we know, the mean p hat is equal to the mean, which is the p in this case is the mean. So that will be that. So now to determine the standard deviation of the sampling distribution of p hat, we need to go ahead and follow this formula. So this formula right here is going to help us get the standard deviation of p hat. So in this case, we already put the p and the lowercase n, which is this portion right here. We're going to use this and to plug it into here. So that's going to be p equals 0.2. 1 minus 0.2 is 0.8 over 150. So from there, we're going to square root this portion right here, which is going to lead us to our answer. So 0.2 times 0.8 is 0.16 over 150, which gives us 0.03265. Alright, so here they want us to get to round to 6 decimals. So right here we have 1, 2, 3, 4, 5, 6. Wait, 5, 9. We forgot our number. So since right here it's 0.03660, it's because this rounded up to this, so which gives us 3, 0, 0. This is what we get. Alright, since we know that it's a normal probability, we're gonna go ahead and construct a graph, and I'm gonna go ahead and label the mean and the standard deviation of p hat. Alright, so that's that. So we are trying to solve for 0.26, so 0.26 must be somewhere around here, and it wants to the right of 0.26, which is this portion. So whenever we're solving a normal probability, we need to go ahead and do normal CDF and go ahead and plug 0.26, and since it's going to the right, it's going to go to infinity, and the mean, the portion right here is mean, so it's 0.2, and the standard deviation is this right here. So we go ahead and use this, we go ahead and plug this into the calculator. So it's going to be right, so normal CDF 0.26 which gives us this right here, which is 0.0331, and that this right here will be, since it's decimal form, this portion right here is going to be 3%, 3.31% to the right of the p hat greater than 0.26. Now, proportion C, it's asking what is the probability of obtaining x equals 24 or fewer individuals with the characteristic. That is, what is capital P, open parentheses, p hat is less than or equal to 0.16. So now we're doing this similarly to what we did for portion B, but for this one it's asking less, 24 or fewer. So instead of going to the right there, we're going to go to the left. So let's go ahead and draw the little normal distribution, and p hat equals 0.2 is equal to 0.3260. So this time it's asking for 0.16, so 0.16 is going to be somewhere around here. So we're trying to figure out the area on this portion, the percentage of the area right here. So we're gonna go ahead and this time, instead of putting in 0.16 to the infinity, we're gonna go ahead and write down to the negative infinity. So it's going to be alright, so we go ahead and plug that into the calculator. So it's the second bar is normal CDF negative 999. So I put a plus sign. So I'm going to go ahead and fix that. So this is what I get once I take off the positive sign that I mistakenly put after. So I get 0.1103. So this portion right here is 11.03%.